Good morning, my dear serious students. Here is your favorite Durga Shankar sir. Today's topic is 9th standard NCERT, chapter 8, motion, chapter 9, force and laws of motion, and work and energy, chapter 11. I like to discuss all the three chapters together because, to my consideration, all the three chapters concept are actually can be combined into a single chapter, because every concept is based on the previous concept, and there is a clear link between all the three chapters. So let us discuss today all the three chapters together, and we will appreciate that my concept, why all the three chapters should be discussed together. Now let us start with chapter 8, that is motion chapter. Now what is motion? Motion is actually, we can say, any object. Any object means it is maybe living or non-living. Even I myself is an object, you are object, because in physics everything, whether living or non-living, can be considered as object. Any object changing its position with time, like this board. Board is fixed here, hanging. It is not changing its position with time. So it is not in motion. So not in motion means opposite of motion. So this is motion. Opposite of motion we call it is rest. Not in motion. Not in motion, single word is rest. Means with time, this board is not changing its position. Suppose I take this pen and I am changing its position with time. So I will call this pen is in motion. Okay, so this is the concept of motion. When it is changing the motion, changing the position, that is meaning motion, then it is describing some distance. Suppose it was in the position A, now it has come to position B, so it has described some distance. Now suppose it can go to B, first it is coming to C, then from C to D, C to D, then D to E, then E to F, then F to D. This way I can, and finally from B to it has come back to A. So what is the distance which covered? What is the distance is covered? Distance covered, you can say AC plus CD plus DE plus EF plus FB plus BA. This is the distance. This much, all the change of position we consider. That is the distance. But when we consider as displacement, consider the displacement. Displacement means initial place. Initial. Okay. Initial means starting. Initial means starting. Initial to final. Initial to final. And here we can consider this case. Here initial point was A and final point also A. So what is the displacement? Displacement here becomes zero. Zero. Because the straight line distance between initial and final position or point is called the displacement. Here straight line distance between A and A is 0. So displacement is 0. Understood? So this is the difference between distance and displacement. In physics, every term is mentioned or denoted, indicated with some symbol. So distance and displacement, this is symbolized as S or sometimes D. Okay, and it has also unit. Unit is meter. Always it should be considered as meter. If unit is not given in meter, is given in some other unit, that should be first converted into meter, then you can do other calculation. So, these are the concept of distance, motion and displacement. Okay. Now, when it is changing the distance or displacement, now I like to make it clear in your throughout the book up to 10th standard or any higher study, whenever you are talking about distance, we are actually talking about displacement. When you are talking about displacement, it is displacement. Means don't take it in other way. Distance means it is all the way displacement. We are talking about displacement. Now distance and displacement, so it is clear now. Distance means no particular direction. So only magnitude. Only magnitude. Okay. Direction is not considered. I have written direction and I cross it. Direction is not considered. Only magnitude. So this is called scalar quantity. This is called scalar quantity. And when it's a magnitude plus direction. Yes, direction is there. Then it is called vector quantity. So from here our discuss up to this time. So distance is the scalar quantity, and here for vector quantity is displacement. Hope it is clear. Now, rate of change of distance. Take this rate of change. Rate of change of distance. Rate of change of distance, if I consider rate of change of distance, then it will become speed. But when we say rate of change of displacement, rate of change of distance is speed, and when we consider rate of change of displacement, then it will be velocity. But here speed and velocity both is denoted by u or v. Okay, like distance or displacement, it was denoted by s or sometimes d. But here, in case of speed or velocity, it is u is initial velocity and v is the final velocity. And in here, like distance or displacement, there should not be any confusion. Whenever you are talking about distance, you consider displacement, and displacement is displacement. Here also, when you are talking about speed, we are talking about actually velocity, and velocity is velocity. Clear, no? Now, suppose, and as I told, rate of change. Rate means with respect to time. Rate means with respect to time. So, whenever talking about velocity, rate of change of displacement with respect to time, so we can get a formula V is equal to S upon T. So this is the first formula, and its symbol is V and unit is meter per second. Distance is meter and time is second. So velocity meter per second. Now this formula is applicable for only uniform motion. Uniform motion only. Like light move with uniform motion. Okay. If it is, suppose we consider our motion in the with a car or any other vehicle, then when we are moving, we cannot move with a uniform motion. Sometimes we have to speed up, sometimes we have to slow down, sometimes we have to stop, we have to apply accelerator or we have to apply brake as per our requirement. So we cannot call that we are moving with uniform velocity. Am I clear better? So we are moving with non-uniform velocity. Means, suppose we consider we are increasing the velocity. Initial velocity, for example, suppose initial velocity was 4 meter per second, and we speed up to 8 meter per second, and within 2 seconds we apply the accelerator, and within 2 seconds we have speed up from 4 meter per second to 8 meter per second. Then what is the rate in change in velocity? Rate in change in velocity. I told you rate means always with respect to time. Rate means with respect to time. That is rate. Now change in velocity. In final velocity is 8 meter per second. Initial velocity was 4 meter per second. And how much time it has taken? 2 seconds. Okay, 2 seconds. So what is the calculation? 8 minus 4, 4 divided by 2. We cut this is 2. That is 2 meter per second square, because you can see second once coming for velocity and second another coming for rate, finding out the rate with respect to time. So this is 2 meter per second square. Second has come twice. See, this rate of change of velocity has a single name. That single name is acceleration. 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 And it is symbolized as A. I told you in physics everything is symbolized. So we can come to one formula. A is equal to V minus U upon T. Okay? So this is the formula of acceleration. A is equal to, now if you cross multiply this, it will become AT is equal to V minus U, and it gives V is equal to U plus AT. This is the second formula of the motion. second formula of motion. Okay, and this is for non-uniform velocity. I am not going in very detail of the formula because then that video will be very long video. To make it shortcut, I just write down the formula. First formula it was V is equal to S upon T, is for uniform velocity. But when it is non-uniform velocity, it becomes V is equal to U plus AT. U is the initial velocity, V is the final velocity. And if it is a retardation, means applying brake, that plus becomes minus. This is the only difference. And when it is covering some distance, means or displacement, then the formula will be S equal to ut plus half a t square. I am not going to discuss in detail how the formula has come, and that will be in another video. And when the time is given in the problem, that time this formula will be applicable. If time is not given, then V square is equal to E square plus 2AS. See here, so this is formula number 1, this is formula number 2, formula number 3 and formula number 4. When you look at the numerical problem, you collect the data and see whether time is given, then you take the formula number 3. When time is not given, then take formula number 4. So these are the about motion. And about motion, we have just discussed what is the concept of motion, what is the concept of distance and displacement, what is the concept of velocity, what is the concept of acceleration, and how they are related to each other. Means velocity is related to distance and time, that is V equal to S upon T, and when it is uniform motion. When it is non-uniform motion, then V will be equal to U plus AT, and distance covered by the motion is S equal to UT plus half AT square when time is given. When time is not given, then V square is equal to U square plus 2AS. Now motion cannot be on its own. Any object cannot start moving on its own. If it is in rest, it will remain in rest. If it is in motion, it will remain in motion. It will not stop on its own. And if it is in the rest position, it will not start move on its own until and unless one agent is working on it. Agent means this agent is force. Agent means something who make the work done, but it itself do not do the work. That is called agent. So force, we can define the force in such a way that force is an agent which make the body in rest to motion, or the body in motion to bring into rest. That is called force. Okay, so we can define. So we are moving to the chapter number 9, that is the force and laws of motion. So the force, we come to the idea, and when we are going to define force, then the first law of motion comes into the picture. First law of motion, it is called when one external force, unbalanced external force applied on a body, the body in rest remain in rest, the body in motion remain in motion in its uniform velocity with the same straight line. This is the first law of motion. That means first law of motion indirectly talking about the definition of the force. And another concept, one is definition of force, and another concept is inertia. Inertia. Inertia means this is the state of body. This is the state of motion, we can say. State of motion. State of motion can be two. One is, we can say, it is state of motion whether it is in rest or whether it is moving. It is at rest or it is in moving. When it is in rest, it will remain rest until one force is applied on it. When it is moving, it will keep moving. It will not stop on its own until unless some external force apply on it. So this is the concept of inertia, and this is the concept of definition of force. So this is the first law of motion. First law of motion of Newton given first law of motion. Now, when it is in moving, when it is in motion, suppose we are not taking the rest, we are taking in motion. When it is in moving or in motion, then it will be multiplied with, velocity will be multiplied with some mass of an object, then m into v, we call it is momentum. Because momentum depends upon two things. One velocity, another is mass. When light body is moving with the velocity, one heavy body is moving with the same velocity, both cannot have the same momentum. The heavy body will have more momentum, light body will have less momentum. Suppose one scooter is moving and from opposite side one truck collide with the scooter with the same velocity or at rest, then also the scooter will get damaged. Truck, nothing will happen. So here, because the truck has a huge momentum because of the huge mass, so there is another concept that is called momentum. So momentum is the momentum. Momentum is the one concept that is mass into velocity. The very new concept, momentum, and very useful concept to understand the laws of motion. The laws of motion. To understand laws of motion, we have to concept clear concept on momentum. Now, rate of change of momentum. Rate of change of momentum. This concept means rate of change of means with respect to time, that I told you, with respect to time. Okay. Rate of change of momentum is directly proportional to the applied force. Directly proportional to the applied force. This is the Newton's second law of motion. Very important law of motion. Newton's second law of motion. And from here, I am not going into the direction. From here, we got the formula of force. F is equal to ma. Okay. To make the video shortcut, I am just coming to the formula. F is equal to, this is the applied force F, and rate of change of momentum, finally it becomes ma, mass into acceleration. So force unit is Newton or meter per second square, mass meter per kg meter per second square. Newton or acceleration meter per second square, mass is kg meter per second square. This is the force. And from chapter 8 we got A, formula of A. So here we can, detailed formula you can write V minus Q upon T. Now can you appreciate there is the clear link between chapter 8 and chapter 9. So force is equal to mass into V minus U upon T. We consider like this. Now some problem will be given. You have to find out the acceleration and then you can multiply with mass then to find out the total amount of force applied to make this motion done. So this is the concept of momentum and the calculation of force applied to bring the change in momentum. Now there is another concept, momentum of an object or before action or before after action. Okay. With a total momentum, suppose we are considering two body together. Two body together. Two body together means, suppose I take a rifle here. Okay. One rifle here, and inside the rifle there is a bullet. Two body together, rifle and bullet. So momentum before the fire or after the fire, total momentum of the bullet and rifle will be unchanged. That is the law of conservation of momentum. Law of conservation of momentum. Means before or after action, any activity, momentum never change. It never increase or never decrease. The momentum before action, momentum after action remain unchanged. It is the law of conservation of momentum. And this concept, the idea of third law of motion. Third law of motion. So, what is the third law of motion? This is the second law of motion. Third law of motion is telling action and reaction equal and opposite. Means when bullet is going very huge speed, high speed, it is giving a reaction to the rifle. Okay. So if bullet is moving with the mass, very small mass and high velocity v, and so this direction, and here is the mass is very high mass, velocity is very small, so this will be in opposite direction. Before it was the total momentum was 0, after the fire is done, then the total momentum also remains 0. That means every action has equal and opposite reaction. That's why the law of conservation of momentum concept comes forward. Understood? So this is the consider of the reaction. Third law of motion talking about there is every reaction for every action. Okay. So first law talk about the force and inertia. Second law given the formula of force, and third law talking about action and reaction. These are the concept of force and laws of motion. Then after in the second law, second chapter means chapter 9, what we can conclude that it is talking about force and laws of motion. So force is nothing but some agent which make the work done or make the body to move from rest to motion or from motion to rest. Then doing this thing, it follows some law, Newton first law of motion, second law of motion and third law of motion. First law of motion is define the force and the inertia of the body. Second law is giving the formula of force, and third law talking about conservation of momentum, that is the concept of reaction of every action. Now let us move to the concept of work. That is the chapter 11. Work in our normal day-to-day life idea about work is not applicable here. Work means, in physics, work means when you are applying some force and due to that application of force, some distance or displacement is taking place. Then only we can consider work is done. Suppose you are keep pushing a wall throughout the day and you are very tired, become sweating, and become very hungry, thirsty, then also we'll say you have not done any work because you cannot move the wall. So there is work is done. This is the concept of work in physics. So work is work is equal to force into displacement, and I told you in physics there is always some symbol. So symbol of work is W, and force is symbol is F, and distance I told you this is symbol as S, and there is a unit. Unit is joule. Work unit is joule. Okay, force into distance or displacement, that is the unit is joule. Now to do some work, we have to take the help of another agent, that is called energy. We can do some work with the help of some energy only. So energy, what is energy? Energy is the ability to do work. That means what is work? With the help of energy, what we are doing, that is work. So energy and the work is just like the two sides of the same coin. That's why energy unit also joule. Energy unit also joule. When you take a coin, is one side written work, another side written energy, all the same coin. Both the unit is. So we are doing due to energy, that is work, and we are doing work, that is the ability of energy. That is the work. So if we make the link with the previous chapter, work is equal to, we can make like this, instead of F, we can write M into A, mass into acceleration. Okay? And distance, distance formula, so many formulas are there. Distance equal to means for S equal to 2 plus half at square, that is distance. Or if it is uniform motion, S equal to Vt, whatever may be. So we can make the link with the previous chapter and we can make this thing more considered. Clear? Now this A also can be made that V minus U upon T and that N into S. This is a complete formula you can write like this. Now energy is the form of energy. Energy has different form. Different form of energy. Form of energy that can be the EP, potential energy, EK, kinetic energy. When one body is in rest or it has some certain height or some changes position, changes shape, it has ability to do some work. Suppose if I say throw this pen, you take the hand back first, then throw the pen. Why you are taking the hand back? Because to gain some potential energy in the pen. We are changing the position of hand. You are changing the position of hand. That means you are gaining some potential energy. Then you are throwing with the force, with the jerk. So this is the potential energy. The potential energy formula is mgh. Potential energy. Okay. Because work done formula F into S, energy formula also F into S, because here mg is equal to actually force, and H is equal to actually S. So again that F into S, this formula coming, because what I told, work and energy is the same concept, is the two sides of a same coin. So half into means m into g into h, this is the potential energy, and for kinetic energy it is half into m into v square. It has some different calculation, different derivation, how half into m into v square has come. Now when the problem is given, go through the problem very clearly. Whether body is motion, then half into mv square will be applicable, and if it is in rest, then m into g into h will be applicable. Clear? Now these are the work and energy. This is the relation is done. Suppose if I ask you what is the work done to bring the a 10 kg object from first ground floor to fourth floor, then you just 10 kg objects, mass is 10 kg, g is 9.8, and height from ground floor to fourth floor, height is suppose 20 feet, height is 20 meter. So that is will be calculated, and this is the work done, or this is the energy applied. Work done, energy applied, all the same concept. Okay? Now, finally, we are again, for every time we are doing the rate of. So here also we can do the rate of doing work. Here also we can find out rate of doing work. For every time we are finding out work rate, so here also rate of doing work, and rate I told every time, rate means with respect to time. With respect to time, rate of doing work. So doing work is W, rate is T, and this is the called P, this is power. Rate of doing work is called power, and power is a unit is, power unit is watt. Power unit is watt. So 1 watt is equal to 1 joule. 1 joule divided by 1 second. Joule upon second equal to watt. Okay? So if we combine all the formula together, so power P is equal to work done, F into S. F is mass. F is equal to mass into acceleration G minus U upon T. Mass into acceleration, okay, and that is force, and distance it is S, and divided by time. These are the complete formula of considering all the chapter. Now, before we finish the video, we must touch one more point, that is commercial unit of energy. Mean we are consuming electrical energy every moment at our home, in industries, factories, everywhere, hospital, office, everywhere we are consuming electric energy. Now bill come every after 2 months. Actually it should come every after 1 month. that is a different case. Let us consider that energy we are getting the bill, that is energy consumption or power consumption. Let us calculate. What we told here, that P is equal to work upon time, or we can say P is equal to energy upon time. Instead of work we can write energy, but formula is even same. So power is equal to energy upon time. Okay, so if we multiply power into time, then we will get energy. At our home, the electric bill is coming in unit. Suppose you will, when bill come now, in the bill it is written, you have consumed, suppose 200 unit of electrical what? Power or energy? Let us see here. So unit is equal to kWh, means kilo watt hour. Kilowatt hour. What is watt? That is power. What is hour? That is time. So kilowatt hour, that means power into time, that means energy. Our electric bill come in energy only. How much energy you have consumed? Energy only, because power into time is energy. So 1 kilowatt hour is equal to 1 unit. Okay. Suppose if I take a bulb of 100 watt and if I make it on for 10 hours, that 10 into 100 into 10 equal to 1000 watt hour. So 1000 we take 1 kilowatt hour. That means 1 unit. Hope it is clear how the electric bill is calculated. So by this we conclude our today's video, and now you can appreciate my concept that all chapter 8, 9, 10 should be discussed together, because all are related to each and one another. Now take the textbook with you and make the video pause and listen it time and again, and I hope your concept will be clear. Thank you.